than just that because of these common mistakes that I don't think are that common. I don't know, I'd have to show you some people's tests and be like, don't you think that's strange that they both have this? And that's strange. And we could talk about it, but nobody has time for that. Needless to say, if you did magically pull off cheating on this past test, or you've been cheating on the test for a while, I don't know what you're going to do on this third one, because it builds on the first two, especially the most recent one. So this third final Chapter 5 test, which is this Thursday, it's building on all the other stuff we've been learning in Chapter 5. So if you've been tuning out Chapter 5, I don't know what you're going to do. You need to come see me, come to zero period, do something. Okay, if you were one of my zeros on the test, and you would like a chance to relive your life and to do it differently, I will gladly give you a different version of the test this Wednesday. But that is my one day, my one shot. Wednesday morning, if you want it, come. If you don't. Okay. Let's start on number 1 of these math workshops. We're still factoring. Can someone tell me the GCF to pull out? Okay. And what would I be left with? And your group can have a point. Also, everybody got a 5 for Thursday, although clearly my cheaters didn't deserve 5, but you know they needed some points. So everybody got a 5 for Thursday. All the groups got a 5 for Friday, except for 2 specifically mentioned in the notes. Table 5 and Table 6 were called out that they weren't listening, supposedly, but I've already discussed it with 6. And I could probably guess 5 too. So I'm assuming it was all okay. You only got a 4. It's not like it really hurt. Okay, on number 2, what should I do? There are 4 terms. Thank you, Jay. I'm going to do grouping. What should I pull out?
Take out 3D, and you'll get t minus 7, and then take out 5, and you'll get t minus 7.
I need to take out a negative 5, and I'll get t minus 7. Okay, and your group can have a point. So I've got 3D minus 5 and t minus 7. Perfect. Number 3. So that multiplies to 64. Four and what? Yeah, I mean 8 times 8 is 64, that's true. I bet 4 times something is 64. That's also true. Just need to know what that something is. Is that what I should use? Well, no, 16 and 4, that only adds to negative 12. I need to add negative 8, so that's not it. So we tried 16 and 4. We tried 8 and 8. Got any other options? Curious. I mean, that's true. It's true that those two multiply, but yeah, they're just not going to give us negative 8.
Isn't 6
No, because 10 times 6 is 60. And 10 times 11, 6 times 11 is 66. So close, but not quite. We did 1, 4, 8. We didn't try 2. 2 and 32. I mean, that's not good either, but 1, 2, 4, 8. 3 does not go. Two points if you can guess what I'm doing.
minus 64 by...
No. I'm doing what? What'd you say, Richard? What'd you say I was doing? I am taking out my graphing calculator, but what am I doing on my graphing calculator? No, I didn't even bother doing that. I'm beginning to think this is not factorable, which would mean it would have how many imaginary solutions then? It would have 2 imaginary solutions. Thank you. 4, was that you first? Thank you, 4. Okay, so that would mean it doesn't cross the x-axis, right? So why don't I just graph 8 squared minus 8h plus 64 and see if it crosses the x-axis. If it does, I have an answer. If it doesn't, it doesn't factor, so I need to move on with my life anyway. Okay, so I typed in x squared minus 8x plus 64. I pressed graph. It looks like it does, but if I actually zoom fit, because I'm telling you, zoom fit's my favorite. If I actually zoom fit, it makes it look like it does. My other favorite is zoom standard, because then it looks like a 10 by 10. But when I do zoom standard, I get real sad because I never even see it at all, meaning that it's so above this that it doesn't even show, which means no, it does not cross that x-axis, so this is not factorable. We discussed last week if it wasn't factorable, so that means there's two imaginary solutions. We did discuss a way we could find the answers, although we're being kind of lazy, so we're not going to bother. How could we find the answers when we have a quadratic like this? What formula? What's it called? I've used all the words in the sentence. If we have a quadratic like this and we cannot find the roots, what formula should we use? The quadratic formula. Yes, you can have your point, Mike. But we're not going to bother. We're going to just move on to number 4. Okay, moving on to number 4. It's my favorite. Why is it my favorite? Ms. Mercer said it. It's the difference of two perfect squares. 25 is 5, so I know there's a 5b and a 5b. What's 361? You memorized these. You took a test on it. Plus 19 and minus 19. Thank you, 6. So you can help me handle that. I appreciate that. You can have your point. Okay, well, since we're talking about things, and Miss Brister at least realized it was the difference of two perfect squares, and that you're supposed to factor. Even if this problem was set equal to 0, I hope Miss Brister would do this first. I hope Miss Brister would not do because that's not what we've been doing lately. We've been factoring. So I have quite a few people who on the last test, like on these two problems, 5 and 6, where it's the difference of two perfect cubes, instead of factoring, they just said x cubed equals 64 and they gave me an answer. 8x cubed equals 27 and they gave me an answer. They did not factor. We've been talking about how to factor. So if that was you, you might want to see me as well. Okay, that's all I got to say about this. Let's go to your new notes. So last week we started, well, at first we were graphing in our heads, which is great, and I love that you now know, like, a cube is supposed to be a snake, a fourth is supposed to be a W or an M. Like, that is very helpful, especially when we make typos in our calculator. And I'm giving this back to you now. So there's no need for Patrick to miss any graphing ones anymore because I'm giving this back to him now. He couldn't have it on the middle chapter 5 test, but on the next chapter 5 test he gets the graphing calculator. Well, since he gets it back, you know what that means for me. We're changing the degree because you already know how to do 2, 3, and 4. So now we got to look at higher ones because you already know how to do the lower ones. So there's going to be some higher ones and some more complicated 2, 3s, and 4s. Okay, we talked a lot about how to graph, not using our calculator, and how to factor. And that was our last test, and it only had 10 problems. So unsurprisingly, we should move on to the next test pretty quickly. On Friday, you were supposed to use the remainder theorem, and basically, to summarize it, it said, instead of f of 4 plugging in a 4 everywhere, which might take a little while, if they ask you for f of a certain number, use synthetic division. The remainder you get with synthetic division is the same number you would get if everywhere I saw an x, I plugged in a 4. So they call it synthetic substitution, but they're just trying to make your life easier. So like on number 8, which I'd hoped you'd done on your own, instead of plugging in, it said it wanted f at -3. instead of plugging in a -3 everywhere you saw an x, you could just use synthetic division with -3 in the house, and the remainder you get is the answer. Okay, so synthetic substitution is great. It leads to something I'm going to skip over and possibly regret later in life. It leads to this, which is more synthetic division. What if they told you one factor? Couldn't we then factor this or use synthetic division to try to figure out all of the roots? And that's what we're going to get to today. So we're going to skip this bottom and go to the next page. Gracie, don't have this? Yeah, last Monday? So the 29th? Okay. The next page tells you about something called the rational zero theorem, which is great, but I'm terrible and I don't really use it that often. So this theorem says, which I'm going to briefly describe to you, it says if you look at the leading coefficient, which is a 1, and you look at the one that's not going to x with it, the 24, if you list all the options, like the only options for 1 are +1 and -1. If you look at all the options for 24, well, that could be 1, 2, all the things that multiply to 24. 3, 4, 6, 8, 12, 24. My gosh, you can see how this list takes forever to list out. And if you do that, you could do P over Q. This is the P. This is the Q. And that could help you make some guesses about where my roots are. So maybe I have a root at 1 over 1, or 1 over 2, or 1 over 3, 1 over 4, 1 over 6, 1 over 8, 1 over 12, 1 over 24. -1 over all that again. So you can see how, while that's great, and yeah, that does give you some starting points of maybe I should check 1, 2, 3, 4, 6, of which numbers to check. It's just too long of a list. No one has the patience for that. Who has the time for that? I'm sure it was great when they didn't have a graphing calculator, but you and I are going to cheat and use the graphing calculator, and that'll go ahead and give us a better guess of where to start. So while that rational zero theorem is great, and maybe one day you'll see a question about it, and you just need to know, basically, I'm supposed to list the factors of the first and the last, and that gives me all my options. While that's great, that's not how we're going to do it, because there is an easier way, because we get our graphing calculator. Okay, so on the next page, we're going to start with number 1. We're going to graph it on our graphing calculator. So I go to y equals, I'm typing in x to the third plus x squared minus 17x plus 15, and I press graph. Now, I already knew, since it was a cube and had a positive leading coefficient, that it was a snake going up the wall. Now, is my snake fully showing on the screen? No, of course, the top of my snake is off the screen. But I knew it was going to be a snake going up the wall, again, because if I know the basic graph, I know whether or not I typed it in my calculator correctly, at least. But now we need to find all the zeros. And I can figure out most of the zeros from looking at my calculator. I'm betting the zeros are at 1, 3, and -5. And I'm probably right. Now, we've talked before about second calculate, and that's terrific, and you can use it, but I've gotten a little lazier. If you don't want to second calculate and actually do 0, instead you could press trace and then guess. So, like, I think 1 is one of my zeros. So if I press 1, and it says y equals 0, then I'm correct. So if 1 is one of my zeros, that means 1 should divide into that thing we were given. So let's go back to our problem. I cheated, and I found out that 1 is one of the spots it hit. So I know 1 is one of the zeros. So I know 1 is going to go into this evenly. So I'm going to use synthetic. If you'd rather use long, you can. 1, 1, -17, 15. And so I'm really combining both things because now I'm doing what we were just testing on, kind of, 2 tests ago. And I'm still doing graphing stuff too. So I bring number 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 15. Negative 15 times 1 is negative 15. And good, I know I'm completely right because I wasn't supposed to get a remainder. If I had gotten a remainder, that would mean the graph didn't cross at 1. The graph did cross at 1. So yay, me, I can do math today. Now, yay, we found one of the answers. But we've still got to find some of the other answers. So it used to be a cube. So now if I'm using this to figure out the rest, I've got x squared, because we go down a degree, plus 2x minus 15. So far, I know I've got this, and I know I have, do I put x plus 1 or do I put x minus 1? Because it's got to be the opposite sign. You can have a point. Okay, so can I factor this? Is this an easy factor? I heard a yes. Somebody told me how to factor it easily. I could use, heck, I already know what the answers are because I've already cheated on my graph calculator. I know it's supposed to be, it looks like a 3 and a negative 5. Again, cheating, but hey, it's a good, I'm telling you, you're allowed to use, it's not cheating. I'm using this to help me. So I'm assuming it's a 3 and a 5. So x minus 5, x plus 3. And the reason I'm thinking that is negative 5 plus 3. Ooh, I've done that wrong. Plus 5 and minus 3. Positive 5, negative 3 gives me a positive 2. Positive 5, negative 3, negative 15. That's correct. And so my answers are what you and I thought to begin with. We've got a 1, a negative 5, and a 3. Maybe I could be nicer and list those in order of negative 5, 1, 3. That would be nicer of me, but it doesn't matter. Now let's not lie. Arturo knew those were the 3 answers to begin with. Arturo saw those were the 3 spots it crossed on his calculator. He pressed trace. He confirmed, for instance, that 3 really was an answer because at 3, when he plugs in 3, he does get y equals 0. He confirmed that negative 5 was also an answer because at negative 5 he also got a 0. So Arturo already knew those 3 were the answers from his graphing calculator. So did Arturo actually have to do all of this work we just did? No. No. But Arturo needs to understand how to do this work because, you know, while number 1 is nice and beautiful, on number 2 and number 3 and number 4 and etc., we're going to have some imaginary roots, we're going to have some decimals, we're going to have some real pains in the rear that are not near as nice as this. So even though Arturo would have gotten the right answer to begin with, he still has to know the process of combining what he just tested on and his graphing skills so he can for sure reach the 3 zeros because it's a cube, so he should have 3 answers. Okay, let's go to number 3. I'm going to come back to 2, but I'm going to go to 3 first. Let's go type it in and graph it. So x to the 5th minus 8 x to the 3rd minus 9x. And I press graph. And it looks like I have 3 answers. It looks like negative 3, 0, and positive 3. But you know, I might be wrong. I could press trace and say, negative 3, are you really an answer? Yes, it is. Trace. 0, are you really an answer? Yes, it is. Trace. Positive 3, are you really an answer? Yes, it is. So, yes, Tyreek has already figured it out, and that's why his group gets the point. I already know the answers are negative 3, 0, and positive 3. And that's terrific, except what degree is this polynomial? What degree is this problem? It's a 5, and how many answers did they give us right then? 3, so we're missing 2 answers. So we're going to have to do some math because we need 5. Now, since those 5 aren't crossing the x-axis, either they're imaginary, something weird's going on with them. But we need 5 because it's a degree 5. Arbitrary is 1 point. Okay, so I still need to factor this. And number 3 is actually a really easy factor at first. Why? What can we factor on number 3? What can we do first? There's a GCF.
X.
Arbitrary gets your point. So exactly what you just tested on of factoring weird things. It's coming into use now. I realized an X went into each of those. We just took a test on how to deal with ones that were to the 4th. What do I normally substitute in? Instead of x squared, I use, you can have a point for my 2 y's. So I'm going to ignore everything for a second. I'm going to change this bad boy to y squared minus 8y minus 9 and see if I can easy factor that. Okay, so I need 2 things that add to negative 8 and multiply to negative 9. 8 and 1. Positive 8 or positive 1? Which one's? Who's who?
1.
Positive 9, negative 1. 9 minus 1 is 8. Oh, yeah. Negative 9, positive 1. So, negative 9 plus 1 is negative 8. 1 times negative 9 is negative 9. So, we actually have y plus 1 and y minus 9. Yes, dear? That's what we just took a test on, isn't it? If you have an x to the 4th problem and you don't know how to factor it, you change it to y. So we substitute in x is equal to y squared. There were 2 just like that on this last test. Okay, and that's great that we factored with y's, but I know our original problem was with x's. So I have x still from the beginning. I'm going to bring him back down to the bottom. And then I've got y squared plus 1 and x squared plus 1 and x squared minus 9. Because while what you and I did was great, our problem wasn't x's, so I've got to go back to x's. Okay, and then this was the easy part. We said each of these equal to 0 and we get our answers. So if I said each of these equals 0, I see with this one I get x equals 0. Check, got it. With x squared minus 9, I would have x squared equals 9, so I get x equals plus or minus 3. Check, got both of those. What should I get with the x squared plus 1?
X equals plus or minus the square root of 1i.
We're just going to put I.
I said 1i.
We were just going to put I. We're too fancy for 1. He got plus or minus the square root of negative 1. And he's like, oh yeah, I'm supposed to use I. So we're just going to put plus or minus I. So yes, we had a list that had negative 3, 0, and 3. But we had to use math to help us figure out the 2 imaginary rates. Because again, my degree was 5. So I should have 5 total answers. I have 1, 2, 3, 4, 5 total answers now. Because negative 3, positive 3, 0, plus I, minus I. Now I've got 5. Okay. I have rambled too much today already. I can already tell you that Seth is going to get a marker and change that test to Friday. So that test has to happen this week. It has to happen this week. He's going to change it to Friday, and we're going to finish this up tomorrow. Back page Wednesday, study guide Thursday, test Friday. If you were trying to get ahead in your life, you would go ahead and start the study guide on the last page. My gosh, you know I'm going to take it up as a grade. You won't get to use it on the test. That is for darn sure. I'm already giving you the graphing calculator. What else do you want from me?